Standard 6.2, solving exponential equations. There are two different types, so the ones that we're doing today for our purposes we'll call type A. We'll look at another type in our next unit. So one of the things that we need to know in order to solve exponential equations is the following property. That property says that if we have a base raised to a power and the same base raised to, another power, then those two powers have to be equal. So if the bases are equal, the powers are equal. Let's take a look at our first example. So here we note that we have equal bases. They are both 7. So if our bases are equal, our powers are equal, we consider exponents equal to each other. And now we're going to solve for x. So I can subtract x from both sides and divide by 2. We get x equals -2. If you want to, you can go back, plug your answer in, just make sure that you are correct. Our second example, our bases are actually different. And so what we have to do is we have to be able to change both of these to the same base. And in order to do that, it is helpful to be familiar with powers of 2, powers of 3, at least to some degree. So we'll come back to this problem in a moment. Let's look at powers of some bases. So powers of 2 would be, for example, 2 to the first, 2 to the second, 2 to the third, which is 8, 2 to the fourth, which is 16, 2 to the fifth, which is 32, 2 to the sixth, which is 64, so on and so forth. Powers of 3 would be 3 to the first, 3 to the second, 3 to the third, 3 to the fourth, so on and so forth. Powers of 4, 4 to the first, 4 to the second is 16, 4 to the third is 64, 4 to the fourth is 256. Powers of 5 would be 5 to the first, 5 squared, 5 to the third, 5 to the fourth, which is 625. So you should be comfortable recognizing the first 4 powers of each of these bases, and then with powers of 2, maybe even a little bit further. So if we go back to our problem here, notice we have base 32 and base 8. And if we scroll back down, 32 and 8 are both powers of 2. 8 is 2 to the third, 32 is 2 to the fifth. And so we're going to rewrite these numbers in terms of the same base. 32 becomes 2 to the fifth, and we still have the outer exponent x plus 4. And 8 becomes 2 to the third, and we still have that outer exponent 3x. Now in our previous videos we learned that when we have a power raised to a power, we are allowed to multiply those powers together. When you're multiplying, don't forget we're distributing the 5 to both the x and the 4. So our new power on 2 is 5x plus 20, and our new power on the other side is 9x. Now that we have established equal bases, we consider exponents equal to each other. 5x plus 20 equals 9x. Subtract 5x from both sides, we get 4x. Divide by 4, we get x equals 5. That is our solution. Again, go back and plug in if you want to check. Let's look at our last example here. Now here we have bases 25 and 1 over 125. We see these numbers 25 and 125 here in powers of 5. 25 is 5 squared. So let's change it to 5 squared. And the outer exponent is still x. And now let's consider 1 over 125. We know that 5 to the third is 125. But this is a reciprocal of 125. Negative exponents allow us to flip. So 5 to the negative third becomes 1 over 125. So we're going to rewrite 1 over 125 as 5 to the negative third power. And again, the exponent is -6x minus 4. Right? Similar to the previous problem, we're going to multiply our exponents together. So 5 to the 2x on one side. And on this side, don't forget to distribute. So 5 to the positive 18x plus 12. Right, now that our bases are equal, our exponents are equal. We can set 2x equal to 18x plus 12. Subtract 18x from both sides, so negative 16x equals 12. Divide by negative 16, so x is negative 12 over 16. If we reduce by a factor of 4, x equals negative 3/4. This is standard 6.2, solving exponential equations.